Hi, welcome to Unit 7, Day 5 worksheet. This is example 1. So just so you know, in this video, I will be showing how to solve for limiting reactant, theoretical yield, and percent yield for these problems. And I'll be starting with example 1 in your worksheet. Now the steps are listed on the side. Prior to this video, you should have watched the intro video, which kind of explains what a limiting reactant is and what a theoretical yield is, and then also percent yield. And so we're not really going to go into that. So if you haven't watched that, you're going to want to watch that first, because this video is all about the problem solving skills that you need to solve it. The other thing I want to mention about this video is, and for all the videos, for step 2 in the process where you're doing the actual calculations, I'm going to show you how to do that using the step-by-step method first. And then at the end of the video, I'll show you how to do it for the one-line method. So what I'll do is I'll have different links for them. So for the step-by-step, since that's first, I'll tell you to pause the video. You can stop the video after watching the step-by-step method if that's the method you prefer. And then for the one-line method, your link will start at the one-line method. Okay, so let's get started. All right, so we're looking for they're asking us to find the limiting reactant, and where it says how much NH3, which is our product, because it's on the right side of the arrow, it can be produced. They're asking us to find the theoretical yield of NH3. And they're also asking us to find the percent yield if 15.2 grams of NH3 is isolated. Okay, so those are the things that they're asking us to find. So basically all 3 things we need to find. Now the first step here is to balance the chemical equation, because remember, we're going to need those coefficients. So let's go ahead and start with that. Okay, so I've balanced my chemical equations by changing the coefficients until all of the atoms are the same on both sides. All right, now that I have that, I'm now going to calculate the amount of each product for each reactant. So what will that work look like? We have 2 reactants here. They gave me 18.4 grams of N2, and the other is 3.25 grams of H2. So I'm going to sort of split this part of the page in half. So in this first part, I'm going to go from 18.4 grams. I want to go from 18.4 grams of N2 to grams of my product. So this is my first reactant I want to try. I want to go from the mass of this reactant to the mass of that product. I'm also going to have to repeat that process for the other reactant. So for the 3.25 grams of H2, I need to figure out the grams of my product. Because remember, once we have the mass of product that can be made from each reactant, then we'll compare them. The number that is the smallest tells us that reactant is our limiting reactant, and that amount of product is our theoretical yield. So we have to do both of these. All right, so now I'll show you the work using the step-by-step method. First thing we're going to do is we're going to convert from the amount of given to the moles of given. So from the mass of N2 to the moles of N2. All right, so to do that, I'm going to need the molar mass, and that means I'm going to use the information in the periodic table. The molar mass of N2 will be twice the amount of 14.01, or 2 times 14.01. So the molar mass is 28.02. That means that 1 mole of N2 is equal to 28.02 grams. Okay, so now that I have that, I want to take my 18.4 grams of N2 over 1, so given over 1, and then use this information in my conversion factor. I want to cancel out grams, so the 28.02 grams of N2 go on the bottom, and then on top I have the 1 mole of N2. Math-wise, it would be 18.4 divided by 28.02. Okay, and then I get 0.657. Moles of N2. Remember, these units cancel out. All right. Next step, we're going to go from moles of N2. So this is going from our moles of given to the moles of find. We're trying to find NH3 here. So from moles of N2 to moles of NH3. And for this, we're going to use the coefficients in the balanced chemical equation. All right, so if you look in the balanced chemical equation, you have an invisible 1, so 1 mole of N2. And in front of NH3, you have 2, so 2 moles of NH3. So that's why we balance the equation to get the coefficients for this step. All right, I'm going to take my answer that I got in the previous step, which are the moles, 0.657 moles of N2 over 1. Now I'm going to turn this conversion factor into the fraction. I want to cancel out moles of N2, so the moles of N2 will go in the bottom, and that would be 1 mole. Again, that 1 comes from the coefficient in the balanced chemical equation. I want to find my moles of NH3, so the 2 moles of NH3 go on top. And again, that 2 comes from the balanced chemical equation. So the math here is 0.657 times 2. I get 1.31 moles. And I'm using 3 sig figs here for all the problems because that's how much I started off with. All right, so then now the next step is to go from moles of NH3 to the mass. And again, I need to use the molar mass for that. So I would have to go into the periodic table. So whenever you're doing moles to mass or mass to moles, you need to go to the periodic table. So sodium is 14.01 and hydrogen is 1.01. That means the molar mass is going to be 14.01 plus 3 times 1.01, which is 17.04. Okay. So 1 mole of NH3 is equivalent to 17.04 grams of NH3. Okay. So again, I take the answer I got from the previous step, 1.31 mole, and this is of NH3, remember, over 1. And then I want to get rid of moles, so the part of this conversion factor that has moles goes on the bottom. And then the mass goes on top, 17.04 grams. Moles of NH3 cancels, and then I'm going to multiply the 17.04 times the 1.31. And I get 22.3 grams. So what this tells me is that 18.4 grams of N2 will give me 22.3 grams of NH3. I'm just going to write that on the top. Okay, now I'm going to do the same thing for H2 from the 3.25 grams of H2. Same process, but I'm starting with H2. So from grams of H2 to moles of H2. Whenever I do that, I need to use the molar mass in the periodic, using the periodic table. So 1 mole of H2, its molar mass will be 2 times 1.01, so 2.02 grams. It's important to note, whenever you see mass and you're converting from moles to mass to moles, periodic table. That's what you should be thinking about using. All right, so here I want to get rid of grams, so I'm going to put the 2.02 grams on the bottom so they can cancel out their opposite, and then the 1 mole of H2 on top, and then 3.25 times, divided by, 2.02 gives me 1.61 mole H2. Now we're going to convert from moles of H2 to the mass of to the moles of NH3. And here we would use the coefficients in the balanced chemical equation. So for this conversion, it's going to be 3 moles of H2 is equal to 2 moles of NH3. All right, so let's take the 1.61 mole H2, put it over 1. And remember, we just put over 1 to make it into a fraction, so there are no units on the bottom of this one. The 1 is just to make it a fraction. And then we want to get rid of moles of H2, so the 3 moles of H2 go on the bottom. And the 2 mole of NH3 goes on the top. So that's going to be 1.61 times 2 divided by 3, and gives me 1.07 moles of NH3. Now from here we go to the moles of NH3 to mass NH3, and again we would use that same molar mass. So I've already calculated it, so I don't need to recalculate it, so I'm using the same one here. I'll just put quotes so I know that it comes from that one. All right, so here we're going to do our moles of NH3, 1.07 NH3, that should say mole over 1. And I want to calculate the mass of it and get rid of the mole, so the 1 mole goes on the bottom, 17.04 grams goes on top, take out my units there, and then times 17.04 and get 18.3 grams of NH3. Okay, so I have my 2 values now. Now I'm going to use those values to figure out which one of these is my limiting, which one is my theoretical yield. Now remember, the limiting and the theoretical yield will come from the one that gives you the smallest amount of product. The 18.4 grams of N2 gives me 22.3 grams of NH3, but the 3.25 grams of H2 gives me only 18.3 grams of NH3. So this is my limiting reactant, and this is my theoretical yield. And remember, that's because it gives the least amount. You can't make more than you have. And my theoretical yield is 18.3 grams of NH3. Okay. Last step is to get the percent yield. So to get the percent yield, you're going to take the actual yield. They tell you that if in this reaction they actually got 15.2 grams, so you see it wasn't 100% perfect. So to get the percent yield, it's going to be the actual amount, 15.2, divided by 18.3 times 100 83.2%, which isn't terrible for a reaction. So this reaction was 82.3% effective. All right, so that is it for folks who are looking at the step-by-step method. The next video, the next part of this video, I'm going to show you the one-line method for solving it. All right, so if you're still watching this video, you're watching it because you want to see the one-line method for solving this problem. So in these problems, what you need to do is you need to find the mass of product that can be made from each reactant. So the mass of the product here is NH3. Massive NH3 that can be made from 18.4 grams of N2, and the massive NH3 that can be made from 3.25 grams of H2. So for the first thing we want to do is let's go from the 18.4 grams of N2 to the grams of NH3. All right, so we start by taking our given 18.4 grams of N2 over 1. And then we need to convert it to, so from amount of given, our mass, to the moles of given. That's our next step, to convert it to moles of given. And for that we use the molar mass, which you would get from the periodic table. So in the molar mass of N2 will be twice the amount of 14.01. And so here's my conversion factor for that. This is from the step-by-step method. I'm not going to repeat the work here, but I'm just going to show you that I have that. So since I want to get rid of grams, so 28.02 grams go on the bottom, the 1 mole of N2 goes on the top. Therefore, they can cancel out. The grams cancel out. All right. Now my next step is to go from moles of given to moles of find. So for that, I need to use the coefficients in the balanced chemical equation. I want to get rid of moles of N2, and right now the coefficient in front of N2 is an invisible 1, so that's 1 mole of N2. And remember, this one comes from the coefficient in the balanced chemical equation. Okay. And then the I want to find NH3. So to find the NH3, I look at the coefficient there, 2 moles. So again, these numbers come from the coefficients in the balanced chemical equation. So when you're doing this middle step, moles of given to moles of find, you're using these coefficients. Okay, next step. And the last part is to go from moles of find to amount of find. And in this case, we're trying to find the grams. So we use the molar mass of NH3. The molar mass of NH3, which I got from using my periodic table, is 17.04 grams. So 1 mole of NH3, and I put the 1 mole on the bottom here so that the moles can cancel out, is equivalent to 17.04 grams of NH3. Okay, so I can do my math, 18.4 times 2 times 17.04 on the top. And on the bottom denominator, it's just going to be divided by 28.02 grams. When I plug that information into my calculator, I get 22.4 grams of NH3. And we're not done yet, because what we need to do now is we need to see how much NH3 can be made from the other reactant, which is the 3.25 grams of H2. So for our next step is to go from 3.25 grams of H2 to grams of NH3. The process is the same. The numbers, of course, will be different. So we take the 3.25 grams H2, put it over 1. Now we're going to convert from grams of H2 to moles of H2. So from amount of given to moles of given, using the molar mass of H2. For that, I go to the periodic table, and I use the information there. Since it's H2, it's going to be twice the amount, so that's 2.02 grams, and that goes on the bottom. So the grams of H2 can cancel out, and 1 mole goes on the top, because 1 mole of H2 weighs that amount. Okay, now we're going to convert from moles of H2 to moles of NH3, and for that we go to the balanced chemical equation. H2 has a coefficient of 3, NH3 has a coefficient of 2. So 3 moles H2 go on the bottom, 2 mole NH3 go on top. And then the last step is to convert from moles of NH3 to mass of NH3, so 17.04 grams, that's the molar mass, we got that from the periodic table, goes on top, and 1 mole of NH3 goes on the bottom. And then when you do the math, you get 18.3 grams of NH3. Now to find your, theoretical yield will be the one with the least amount of product. So a theoretical yield is 18.3 grams of NH3, and your limiting reactant will be the reactant that gave you that amount. So H2 is our limiting reactant, okay? So that's what's written up here in green. In terms of the percent yield, they told you that your actual yield, what you actually made or isolated in this reaction, is 15.2 grams. So you take your actual yield, 15.2 grams, divided by the theoretical yield, which you got here, 18.3 grams, and then multiply that by 100, giving you a percent yield of 83.2%. All right, that's it for this video. The rest of the videos are example videos as well. Have a quality day.